Hey everyone, my name is Ankur Haridosh and welcome to my channel. Today we are doing a question called Populating Next Right Pointers in Each Node Part 2. So here we are given a binary tree and it is not a perfect binary tree, and we have to assign its a next pointer to its directly right node in level order traversal. So I did a video for perfect binary tree, the part 1 of this question. I will leave a link in the description. You can check that out first, then come back here. Okay. Now, the brute force solution would be level order traversal using a queue, and we will just pop out elements from the queue and assign its next pointer to the front of the queue, right? But that would take space, and at maximum it would take 2 to the power L space for each level. So mm, um, that would not be optimal, right? We can do it in space of O of 1 time. So for that, if you have seen my previous video, um, there we just used current pointer and start pointer, and with that we just kept on moving to its left node, and assigning its left and right child pointers next pointer, right? But here we cannot do it because it is not a perfect binary tree. So there are two things: we cannot just keep on moving left, and we have to identify what is the start node of the next level that we will go down, right? So for identifying that, we'll have a start pointer which identifies the next node in the next level that we have to go. The node which is for level order traversal, keep on moving at this level, and current just points to the current level, node in the current level. So um, let's start with that. Now current is currently pointing to the root node. Okay, so current is pointing at the root node of the current level. Now we'll have to identify the start node of the next level, and we'll use node at this level, at its children's level, to assign the next pointers, right? The node will keep on moving in its children. So the first thing we need to do is identify what would be the start node. So start node is initially null. So when we will see that if current's left pointer left node does exist, and we will check then if start is null, then we will assign start to this node. This would be our next starting node when we move to this level, and we will assign node to this as well, because node also did not exist, and it was null before. So from here we will start assigning next pointers. Then we'll move on to the next node in this level. It's this node's right child, which is 3. Now we will see if it exists. It does exist. We will again check if start is null. It is not null, so we will ignore that. And else condition would be we will assign this node to whatever previous node it has. So the previous node, whatever that node would be, its next pointer would be this current node that we are looking at, right? So this node's next pointer would be 3. So now at this level we are done, because its next is null and we cannot move there. So now we will move to its next level, which will move to start. So now current at this level is done. Current is at 2 now. and again we will see uh, what the start node or our next level should be, because this 2's left is null. We cannot, the start is not going to be here. Now this algorithm would be useful. So again we will check if 2's left is null, we'll ignore it. 2's right is null, no. So we will see if start, we have assigned a start or not. Start is null. So now we will assign start to here. This is a start now. We will start this at next level, and we will assign node as well here, because we do not have a previous node at this level to assign something to. Then again, after we are done at this level, we'll move to the next pointer. We are done with this. Now current is 3 at this level. Again we will see if left pointer does exist. It does not exist, so we will skip. Now 3's right does exist, which is 7. So start, we will again see start if it does exist or not. Start is already assigned, so we are done with that. Now the previous node is at 5, so 5's next is 7. It doesn't matter how many nodes we skipped in the middle. The previous node is pointing to 5, so its next node is whatever node we are currently seeing, which is 7. So this assignment has been made. Now this node is done because 3's next is null. Then we will again go to the next node at this level, which is at 5. So now this is done. Current is now at 5. Start at this node is done, and this also is done. So now we'll see if 5's left does exist. It does exist. The start would be here. Node again would be assigned to this. Again we will see if its right node exists. Yeah, it does exist. So we will assign this, make this connection, and move 5 further ahead in this node. And its next is already assigned to 7. So you will just move current to here. Current's left and right pointer does not exist, so we will just end this here. And start node is at 10 now, so we will move to the next level. So for this level it is done, and these are also done. Current is at 10 now, because current's left and right pointers do not exist. We will just skip this node and move to 11. It's also left and right pointer do not exist, so we also skip this node. So now we are done with the question, and this algorithm would work, and we have solved this optimally. Now let's write the code. So just base case, if it is null, we'll just return it. We will need 3 things: current, which points to root, and start, and node, which can also, let's just leave it. So while current is still not null pointer, it does exist. We will again move at its current level, and at this level, if current's left does exist, we'll move there, and you will see that at that node, if start not equal to null pointer, if it does equal to null pointer, then we'll just assign start to currents left. This is a start node. Else, that means that our node is ready. We can assign its next to this current node and move node ahead to whatever its current position is, and again you just copy the same for right pointer. It's basically the same, right? And here again we'll move current to currents next at this loop. So this loop would just do laboratory traversal, and now current at the end would be start for the next level, and we will just return root. I hope this works. Okay. Yeah, we will need to assign start to null every time. Yes. Okay. Okay, this. Yeah, so this solution is accepted. Now, if you enjoyed the video, please like the video. It really helps with the YouTube algorithm, and subscribe to my channel. I will do more questions like this, and leave a comment down below if you need some any help or anything, and if you have any suggestions or something. Otherwise, thank you for watching.